Hi, our next appearance is a special interview with the team from ECMWF, the European Centre for Medium Range Weather Forecasting, and led by Nils Wedi here, who's going to help me ask questions. So you're in charge of something called Destination Earth, which is an EU flagship for a digital twin of the Earth. Don't we have an Earth already? Why do we need a second one?
Yes, thank you very much for inviting us here and giving a brief overview of Destination Earth. So the initiative is really a strategic initiative, as you know, of the European Union and in particular DG Connect. And we would like to help them to bring the Earth system model information much closer to the impact sector applications, like from hydrology, from those, or like energy management, renewable energy management, and really to kind of help decision makers to make better decisions by providing the information in a more readily digestible form so that it can directly be used for policy making, for climate adaptation decisions, or just warning for extremes. And so this is an important aspect to bring these together, impact sectors on the one side, but the complex Earth system model information on the other side.
So that the point that's new that really corresponds to the digital twin, is it bringing all the information together or extending the models?
Yes, it's bringing this information together. It's both integrating as well as interoperating. So interoperating in an emerging and complex field of technology where cloud provision is available, where HPC gets perhaps closer to the cloud and is providing in a way also a data management for how the data is flowing across the HPC to the cloud. So that's part of this development and the interactivity with the data.
So that's a big project, I can imagine. So you brought some friends from the project here to help us.
Exactly. So I brought some friends here. The first one is Tiago Quintino, also from ECMWF, and he is very much in charge in providing the data access from the HPC, from the production side, all the way into what we call a data bridge, which is our data management plan, a blueprint, if you like, for also other disciplines, how to deal with these huge data production rates that we produce on the HPC and bring that actually closer to the user. Tiago, my question to you, how can we do this?
So one of the ways we are really setting ourselves a very, very high challenge of trying to be able to handle 1 petabyte simulations. And to do that, we introduced this new concept of a data bridge. A data bridge is something that stands between the HPC as the big data producer and the users. And the idea is to rationalize that data, transform data into information, make that information more available, more closely connected with the users, closely connected with the needs of the users, the decision makers, that will then be able to explore that data in a scalable manner that is more associated with the way they see it rather than the way we produced it. So that's a big bridge that needs to be crossed, and hence, yeah, a lot of work ahead of us.
But is this going to take care of archival of data and everything long term, or is it just for the user interaction and visualization stage?
No, it also includes the safekeeping of that data for the future, because that data is going to be very precious, and we will keep it for as long as Destination Earth is running. We will keep that data, and people can come back and reevaluate the decisions that they have made, maybe even making better decisions.
Okay, that's going to be a lot of hard drives if each simulation is a petabyte.
Tiago, can you, but one important aspect in Destination Earth is, can you re-emphasize the point of streaming data and programmable pipelines and how we basically offload some of the responsibility of actually keeping the data to the application users?
So you raise a very good point, Nils. In fact, one of the challenges of dealing with 1 petabyte of data every day is the fact that, well, you can just not go through all the data again. So with Destination Earth, we're developing this thing called the Digital Twin Engine, and that's a way of not only helping the modelers do their work better, but also helping the users and the applications that need that data to come closer to the model. In a streaming, we will stream the data such that they can be listening into that stream of data and picking up the parts of the data that they need to do their job in such a way that they don't need to go through all the data again and therefore we'll make this more scalable, and they will be able to actually react quicker because they will be part of the production stream of those production pipelines that feed the data. They will be able to bring in their own code and be closer to the data generation.
Cool.
So one bit further downstream from this data production of these programmable pipelines is in fact the visualization. So we have a contractor, Exprivia, and is working together with CMCC on understanding basically the data and helping them to basically bring the meteorological information, if you like, into the visualization. And the visualization here is part of trying to find information in this petabyte of data. Okay, we have machine learning, but we also want to visually basically explore the data in the best possible way. And so I hand over to Gianluca, who can explain a little bit the concept around this immersive visualization that we envision.
You might want to move a little bit more.
We are developing an interactive system in order to explore the data in a visual way without having any limitation about the possibility to isolate specific phenomena and build a representation in real time using technology that is derived from the game domain, from the game technology, so immersive virtual reality, augmented reality applications. And the idea is to build this digital twin of the Earth with volumetric data, multi-resolution grids. Everything can be customized at real time, so the user has complete control of the way the data look, and they can modify color palette, defining a specific region of interest, so they can understand the problem and explore possible, let's say, visualization solution interactively, dealing and playing with the data.
But this must involve huge amounts of data reduction too, right? Going
Exactly.
from a petabyte per day till a few tens of gigabytes at most, or whatever
Yeah.
you can push through a headset.
The challenge is to have a way to, let's say, isolate and navigate this huge amount of data in order to select what is really important for the user, and the user is in charge. So the user can actually select what he wants and how the style of visualization interactively, and build a sort of narrative that it can be based on interactive stories that can be used for scientific communication, but also for regular media, for teaching and for creating a virtual experience for the general public. In order to do this is not easy. We have to involve scientists that are expert about the data. We are expert about the visualization, but not necessarily about what is the best way to visualize it. So we are using CMCC, which is maybe you can.
Yeah, I'm Paolo. I'm from CMCC, that is the Euro-Mediterranean Center for Climate Change, and we are partner of this project of visualization as a scientific support, let's say. And linking to what Gianluca was saying, the user entering the application will have a global perspective of the world, but we will also develop some use cases to guide the user or the scientists that will want to use the data. So, for example, some use cases could be about extreme event, some event that can be very interesting both for common users and scientists. Could be tropical cyclones, or in this specific case, medicanes that are simul-tropical cyclones. And this type of event could be approached from an immersive visualization to understand both the impact but also the scientific mechanism that are behind these events. Thank you.
But as a researcher, if I've seen something in a visualization, right, when it comes to publishing a paper, is there a possibility to go back or somehow tag frames, tag a visualization? If somebody else in the world doubts my results, how can I share that, well, we saw this in this visualization and here is how you can repeat it? Are there methods available for that?
I have not think yet to this possibility to maybe store the result, maybe with all the palettes and stuff, but surely it could be an option. Specifically, I don't know, if you have a 3D visualization, you want to make a transect of an atmospheric event, it could be really interesting to see the circulation, the cloud patterns, and all this stuff from this perspective.
Maybe I can add something about the exploitation of the results. The system is an application that can be distributed everywhere. You can actually, the idea at the end of the project is to have an application that runs on the cloud and sends directly the frame to end user. So everybody in theory can access directly this kind of system and explore the data without having to install necessarily a system on board. Of course, this is not possible 100% now, but the project has a certain, let's say, perspective.
So this sounds like a next generation of open data sharing too.
Yeah, exactly. So the idea is to use a regular system like laptop, iPads, etc., but also virtual reality and augmented reality glasses in order to explore this data and export this data as video or as a generic notebook that can be exported and attached to a scientific paper. So this kind of.
That sounds great. Nils, any concluding words? How can we, infrastructure, researchers all over Europe and everything, how can we help you? Because this is important to all of us, right?
Yeah, absolutely. I mean, obviously, we are concerned always about having sustainable infrastructures that we put in place, and so we are closely interacting, for example, with EuroHPC because we get the in-kind resources from EuroHPC in order to run some of the simulations and in place the data bridges next to EuroHPC platforms. But as you perhaps know, it's a complex world. The different sides of EuroHPC are run differently. The way identity management is done is differently, and so I think a number of things have to come together, not only viewing really the compute part in isolation and also not viewing, say, Earth system modeling as a source of data information as an isolated silo, but really we should work together to break up some of these silos, work together on like federation, but federation not only access, but really how can we share data in a wider context. And I think this was also talked about in the talk this morning by the keynote.
By Lorena.
By
Yes.
Lorena. Thank you.
Nils, Tiago, Gianluca, and Paolo, thank you so much for joining us, and good luck with your project.
Thank you very much, Eric.